In this video, I'm going to talk about jittered points visualization. It's a very cool type of visualization, and it is kind of unique to ggplot package. Talking about the function of that, the aesthetics is going to get includes X and Y. And something which is cool about this visualization is X and Y can be numerical, as you can see here, or categorical. This makes it very flexible to deal with different data types, and the geometry for this type of visualization is jitter. Let's explore this function with a data set. So the data set I'm going to use is the property data. Let me refresh my mind about the data. Property. I can run the code. I'm going to see the variable names and rows. However, I only want to have one row. Okay, and what I want to do is for explaining this geom_jitter function, I'm going to compare it with the scatter plot, so you will see the benefits of using this function. What I want to do is I want to create a scatter plot. I want to put bedroom in one axis, and I want to put the price in the other axis. So let's start by inserting the first layer. In the first layer, I have to identify the data set, which is property. Then under the aesthetics, I have to identify what goes to X and Y. What goes to X is bedroom, and what goes to Y is price. Okay. I'm going to allocate this line of code to an object which is called P1. So the first layer, including data set and variable name, is going to go to P1. P2 can include the geometry type. The first type of geometry I'm going to use is geom point, which goes to P2. I'm going to create another R object called P3, and I'm going to store geometry of jitter points in this object. Let's first take a look what's going to happen if I create a scatter plot. For creating a scatter plot, I'm going to mix this P1, including the variables, with the second layer of geom point, which is the function for creating the scatter plots. P1 plus P, it should be lowercase p1 plus p2. Let's see what will be the result. This is the result. I have different number of bedrooms, 1, 2, 3, and 4. And this is a typical scatter plot. However, if there are some overlappings, for example, over here and over here, it can make reading the data a bit difficult. Let's go to the top. Instead of mixing P1 with a scatter plot, this time I'm gonna mix it with a geom jitter. Geom jitter is stored in P3. So so by changing P2 to P3, the default of the geometry gonna change to geom jitter. Let me run the code, and you see this is the results. So maybe you're gonna ask, what is the point of using this geom jitter? Please take a look to these two guys, right? The price is almost the same. So basically what geom jitter does, it randomly separates the data. It puts distance between the data, so it makes reading the data a bit easy. Maybe if I was using a scatter plot, since these two guys have the same price, they would overlap, and I could not understand. I have two different data points here. I would think there is only one, same as these two guys, and maybe these two. So it's a small data set, but if it was bigger, I would have more instances of this. By the way, if you think the amount of jittering, the amount of distance is a bit large and it makes you confused, you can come to the top and use the width function and tell him to change the default to 0.2, and the data would be, the randomness of distribution would be a bit less. Let's use a bit more complicated example from the diamonds dataset. So, as usual, we're going to refresh our mind about what's going on in the data set. And let's only have one variable, right? And I'm going to use the ggplot function. The data set is diamonds. The aesthetics, this time let's choose two categorical variables. Let's say x can be cut and y can be clarity. I can save the data set and variables I want to use in an object. The second layer can be talking about I want to use geom jitter, and I can add different layers together in a new line. Running this, this is the result. There are some cool information here. For example, I see this is good, and this is the clarity of SVS1. There are too much data here. When it comes to the cutoff fair and clarity of IF, not too many. And yeah, for example, I see these guys over here are kind of, these guys are kind of compact, less compact, very less compact. It gives me some information about what's going on inside the data set. Maybe I want to change the clarity to color and run the code. And yeah, I see the fair. When the cut is the fair, there are very less amount of data for different colors, but for different cuts, especially very good premium and ideal, there are too much data. This is the kind of information I can get from running this command. Let's use a numerical variable for the y-axis. So I can come here, and where is my y-axis? Maybe I can change the y from color to what? Let's say price. Let's run the code. And again, some good information I can see in what's going on inside the fair. By the way, as a whole, we have less amount of diamonds for the higher price in all of the cuts. But when it comes to fair and good, this having less amount of diamonds is much more sensible. Maybe I can include two different categorical variables for the x and y, or maybe I can do something like this. I can have the x cut for the x, the price for the y, and maybe I wanna give it a color, color by what? Color by cut, or color. Yeah, we can try this color by cut, and see what's going to happen. It looks better. Or maybe I can also use, this guy, this extra layer of facet wrap, and get some extra information. So this is the flexibility that I can get from using this geom jitter. By the way, let's add another layer. The other layer can be facet wrap. Let's wrap them by a new categorical variable. I already used color. I can use color. I run the code, and this is a pretty complicated. Uh, plot. So yeah, an interpretation of this plot is also a bit difficult, but this is the capability that we can get from using geom jitter.